you remember this from Math 20-1? Yeah, actually, you spent quite a bit of time solving rational expressions in Math 20-1. Some huge ones, as a matter of fact, which included all kinds of factoring and all kinds of other nonsense. Do yourself a favor. Go over to the Math 20-1, and it's just the very last few podcasts in the rational expressions section. And watch those again. Watch the algebraic ones because they're really, really cool. And I'm just going to really show you easily how we did this. Remember, rational equation, again, is an equation that has to have a variable in the denominator. That's what makes it rational. Yeah, no kidding. So if we're going to do this algebraically here, okay, you have to remember a couple things. The first thing, figure out the restrictions. Yes, those non-permissible values. They come back to haunt you. One of the reasons why is because what happens if you solve this thing and one of your answers is a non-permissible value? Well, then you can't use that value, can you? So in other words, that becomes, oh, do you remember this? Extraneous solution. Yes. Oh my goodness, Math 20-1 is coming back to haunt you, isn't it? Okay. Now, what are ways of solving this algebraically? Common denominator. Oh, God, that's got to be the easiest way to do it. Also, sometimes, if it's simple enough, you can just cross multiply and solve for x. Well, heck, you did that in grade 5. Right? But the entire thing is to solve for x. And then, again, like I said before, check against those non-permissible values for those extraneous ones, those extraneous answers. So if you solve this thing and you got 2 and 3 as a possible answer, and an NPV is 2, guess what? 2 is extraneous, can't use it. Graphically, there's 2 ways of doing this. Graphically, there's 2. One is, yes, just solve it like it was y1, y2. In other words, you're going to have some sort of function over here equals to some sort of function over here. Let that be y1, let that be y2, and suddenly, look for the intersects. That makes things really, really simple. But now, check this out also. You can do this method number 2, graph it as a single function. What do I mean by that? Well, if you have something over here, a cross at equal sign, something over here, take this guy and just bring it over, which gives you this minus whatever that star was, okay, equaling to 0. Because that equals to 0, remember that 0 was a y at one time. So that means your y equals to 0 means that you're finding the x-intercepts. And when you graph them, look for the x-intercepts. Ah, ha, 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 ha. Okay, so let's do some of this. I'm going to do one question. I'm going to do it both algebraically and graphically. I'm going to show you both graphical methods, but I'm going to show you that in separate podcasts to keep the podcasts nice and short. Okay, so first things first, what can you do in a situation like this? So if you see a situation like this, right away notice that this can actually be over 1. This is nice and simple. This is a cross multiplication question. But look what you forgot to do. NPVs, yes. X plus 6 cannot equal to 0 means that x cannot equal to -6. Watch out for that NPV. It's going to bite ya. Be careful. Okay, so let's cross multiply. Well, that's easy. 1 times 16. Oh, I think that's 16. X plus 6 times 4 minus x. Okay, so now we're going to have to do a little bit of foiling here. And the fact that this is kind of written weird, you know what? Let's just FOIL it like we would normally FOIL. So there's a 4x. Over here would give you your minus x squared. This 6 times 4, of course, is going to give you a positive 24. And then finally, 6 times x gives you a minus 6x. Combine some like terms here, you end up, oh, and don't forget, this whole thing still equals to 16. Okay? You have 16 equals to minus x squared minus, 6x and 4x gives you minus 2x plus 24. Oh, how convenient and pretty that works out to be. Now, here's what I'm going to do then. I'm going to take that 16 and bring it over to both sides here. Oh my goodness, look at that. That cancels out to give you 0. That here cancels out to give you minus x squared. That's still minus 2x. And this is going to give you a positive 8. Now, I don't know about you, but I don't like factoring anything that has a negative leading coefficient. Now, there's 2 things you can do here. You can multiply each side by a -1, changing the sides of both sides. Changing the signs of both sides. Or you can take this whole thing and bring it over to the other side and let it equal to 0. Whatever way you want to do this algebraically in your mind, go right ahead and do it. So I'm just going to say, let's just do this nice and multiply both sides by -1. And look what happens. The -1 times 0, still a 0. This changes every sign over here to give you x squared plus 2x minus 8. Oh my God, you look how pretty that works out. Holy smokes. Now you can simply factor this one in your head, right? You got x minus 4, x plus 2. Do not forget that this actually equals to 0. Okay? Oh, no, it should be plus 4 minus 2. Ah! That's what I get for jumping the gun here. X plus 4, x minus 2. Don't forget the equal to 0. You got x plus 4 equals to 0. That's where my x equals to minus 4 came from. I was one step ahead of myself there. Oh well. X equals to 2. Cross-reference this with your non-permissible values. Remember the non-permissible values? We better go back here and check out what they were. I don't remember what they were. Oh, there it is. X cannot equal to minus 6. So x cannot equal to minus 6, that would complete the entire answer right there. So this actually has two possible outcomes, and x equals to minus 6. That's beautiful. Now, what I want to show you in the next podcast here is I want to show you how to do the two graphical methods. So there's the algebraic one. Stay tuned for the graphical ones.